you still typing? Good. Take your time. We're just going to answer these 5, is it 5? 5 questions.
It's fun.
Huh? And yeah, I said I've been pushing you really hard these last few weeks.
Rough.
Make you do a lot. Same as this stuff. Okay, so what are the hypotheses? They're all always the same.
1 equals 0.
Yeah. And what does that mean? What is that a symbol for? The slope. Good. The slope is 0 or the slope is not 0. And we'll just keep saying this. If the slope is 0, what is that saying in context? In words. Yes, there's no association. It doesn't say to write in words. You don't have to. I'm just reminding you. Okay, number 1's done. For A. So B says check the necessary conditions. Okay, so there's 4 conditions, but really kind of 3, because 2 of them come from the same graph. They all come from graphs. So unfortunately, if the graphs are not given to you, you do need to sketch the graph. So the first thing we have to look at is the scatter plot. So, does everyone remember how to get a scatter plot? If not, second y equals. If it doesn't already, make sure it's highlighted on the scatter plot, and it should say L1 and L2 for your x and y list. Graph. And look, mine looks like this. Anybody else? Okay, what are we supposed to check on the scatter plot? Is it straight-ish? Straight enough that regression makes sense. Is that one pretty straight? Yeah, it would really be straight if we could take this one person out. But you can't. But it's still pretty straight. It doesn't make a parabola or anything. Okay, so we're going to sketch that. It is a sketch. It doesn't have to be perfect, but include some scale. Just hit trace and whatever point comes up. Yours may not be the same as mine. That's the first one. I guess it's the first person. List. Something like that.
We have to label like.
Yeah, any scatter plot you always should. So what is our x-axis? Weight, and our y is percent body fat. Okay, the conditions are easy to check, but you do have to draw a graph. So now you just say the scatter plot is straight enough. So don't just say this without drawing the graph, unless it's given to you. This is the worst part. Just because you have to graph. Okay, so what's the next condition? What do you have to check? The residual plot. So how do we do a residual plot? Okay. Change L2 to residual, Z. And to do that, you do second, stat, and it's somewhere in that list. Was that a question? Okay. I know why mine worked. I was going to go ahead and show you what happens. But if yours says an error or system mismatch, something like that, what does that mean? What do you have to do first?
Save all stuff.
Did anyone's work? Okay, I was gonna say, probably shouldn't have. Mine did because I've already done it. Okay, usually in order to calculate the regression, or to calculate the residuals, you have to do the regression first. So just go to stat, calc, lin reg. You don't even have to look at anything. It just has to have that calculated, and the calculator stores that information and uses it to calculate the residuals. And then you can hit zoom 9 or graph, and it should give you this. Yeah, sketch. Usually won't have this many points either. It's a lot of points. Okay, quickly sketch. What are we looking for on the residual plot?
No pattern.
No pattern.
It like thickens.
It doesn't. It should not thicken, right? So it should be randomly scattered, and the plot should not thicken on either side. So, what do you think? Is it randomly scattered? Does it thicken? Nope. So that's good. So residual plot, or just say residuals are randomly scattered, and they don't, or doesn't. Should have warned you ahead of time to not make your graphs too big. It'll fit. Got one more.
Do you write anything for the scatter plot?
Yes. It's called the straight enough condition. It should be somewhat linear, somewhat straight. So you say it's straight enough, or you say it's linear, somewhat linear. Okay, so what's the last thing you have to check? This one we haven't ever done by hand, I don't think. It's a histogram of the residuals. So you know how to do a histogram. Yeah, change it to a histogram. Well, it'll change the list to L1, and you want it to be a histogram of the residuals. So change your list to residual. And then earlier today we were having trouble if you hit graph, but if you just hit zoom 9 without hitting graph, it should graph it for you. How to change L1? Just second stat, and then keep looking through the list. It's there somewhere. Like that. I did zoom 9, zoom stat. Your scale may be different. It's okay.
Yeah.
Is it
It's just like
a lot different?
yeah.
I can't see it.
It looks like the
Yeah,
line.
it's not right. Okay, so can we just draw it like it's shown?
Yeah, that's fine. There's a little bit of scale there. So what's supposed to be true about histogram? Yeah, it should be near, it's supposed to be approximately normal or unimodal symmetric. Is this one pretty good? Unimodal, somewhat symmetric.
So on the residual, there's no scaling to it,
No.
but the histogram.
Right. Well, what I did to get the scale, I just hit trace, and it shows you the min and the max. That means for that scale thinking, on that first bar goes from about negative 12.5, negative 13 to negative 8, and then the height is 3. And then so you can just do it for one bar, and then the rest are similar. If you forget, I mean, that's not a huge problem, but the more detail you can write is always better. So did you do the 89s, did it look unimodal and symmetric?
It looks fairly like symmetric, but there's like gaps and stuff.
So it had a really wide
Yeah.
spread out. Okay, any questions? Those are all the conditions. You don't have to do that often. If it does ask for the check the conditions and all the graphs aren't given to you, you need to sketch them. Got it? Okay, the rest is pretty easy. So write the equation for the regression line. This should say r squared and r. I don't know what the S is for. Okay, everybody know how to do the regression line? Yes? Is that a yes? Okay, sure. Linreg, stat, cap, linreg. We already did it once, we just didn't look at it.
Good.
Stat, cap, linreg. And if you forget some of the stats, remember I gave you that green paper and it gives you all the hints. I see a few people with those out. It tells you the steps for all this stuff with the calculator. Okay, now we just fill in everything. What's our Y? Body fat. Estimated. B sub O, that's our y-intercept, and it is negative 27.38.
Yeah.
Our slope, 25, and x is weight. What?
How do we know the body fat's y hat? Percent body fat's y hat?
Well, it's the way we set it up. I mean, we put weight in L1 and body fat in L2, so it's Y. What can you say about the correlation?
I mean, it's pretty strong. It's pretty neat.
It's moderate.
It's moderately strong,
Like a
maybe
0.7.
0.7.
It's pretty neat.
Is it positive or negative? Positive. If there's anything you don't understand, please ask. Okay, now it says state your conclusion. So this is, it should say do a hypothesis test. So this is a linear regression t-test. It's in your calculator with all the other tests. Stat test. As you're scrolling through the list, you should see lots of things you know how to do. Should know how to do. There's a few we haven't done.
L1, L2?
Yeah, so it's linear regression t-test. L1 and L2. It should be not equal to. It'll probably always be that. I guess if you wanted to test and see if the slope was positive or negative, you could. We usually won't. Regression equation, just leave that blank. You don't need it, as long as you're using your list. And so you just calculate.
Is this like the t-test that we've known? The same type of t? I'll do that.
Yeah, like we did a different kind of t-test. Is that what you're talking about?
No, I know.
Oh, God.
But does it do the same kind of idea?
Yeah. Yeah, all tests are basically the same idea. Like we could draw a normal model, t-model. We don't. Yeah, so it's all the same concept. So what's our conclusion?
Reject the null hypothesis.
Reject the null hypothesis. So there is evidence of an association.
same time. T.
Thanks for participating and asking questions.
So we have a quiz on Wednesday. Don't we?
Yeah.
Why?
Why not?
Good answer.
Okay, last thing.
Good.
I don't even know what you guys are doing. Talking about. Okay, linear regression t-interval. Now, everybody look, because some people don't have this on their calculator. Let's see if you're one of those people.
Do we have to write like
The formula? Oh,
the name of the test?
yeah, you should.
Okay.
Remember the whole phantoms and panic thing? I mean, the very least, that's not that big a deal.
I was just
Yeah, you should always either write the name or the formula. Name would be a lot easier. Okay, so right underneath linear regression t-test, it says linear regression t-interval. Raise your hand if your calculator does not have that. Everybody has it? Okay, good.
No, I don't have it.
Okay, I was like, I know that I bet someone doesn't. So you watch, and my suggestion, I could show you how to do it by hand, but I would just borrow a calculator for this. Would be the easy way. So everything's like the test. L1, L2, it's a 95%. You calculate, and there it is. It's kind of slow. All we have left to do is interpret that, and we're done. So what are we estimating? An interval is always an estimate of something.
Slope, right?
The slope, yeah, the slope of the line between these two variables. So we're 95% confident that the slope of the regression line between percent body fat and weight is the interval. Oops. Okay, back to something we talked about one time ago. Does that back up our conclusion from D? Hold on. Does that back up our conclusion from D?
yeah, it does.
Yeah, because in D we said there was an association. That means the slope is not 0. Is there any way their slope can be 0 if it's between 0.12 and 0.38?
So can you say that like we're 95% confident that the average association between?
I guess you could.
Because that's what we did on the others.
I don't think we did.